Hi, welcome back. And next video has almost the same scenario as the most recent one. I think that's Dynamics number 7. This is Dynamics 8. The only difference is at this point we start with a greater velocity. Greater velocity, so it means it's moving to velocity or twice the initial velocity. Let's say 2 v meters per second. And then after I drag this, it's 1 v meter per second. Is that possible to happen? Well, maybe I was dragging it before at a different location and there's no friction, and then suddenly there's friction, so that's why it's going to slow down. And maybe the force that I applied wasn't strong enough to overcome the friction, and that's one of the reasons why it might have decreased. So here, in this case, the initial velocity is greater than the final velocity. And again, it's still being dragged along the horizontal surface, so it means there's no motion along the y-axis. So in this case, make sure that you identify that there's no motion along the y-axis. Everything is along the horizontal axis, or also known as the x-axis. So starting by writing down information that I know, the acceleration. So let's talk about the acceleration. So the acceleration of the block, so we all know that there's no acceleration along the y-axis. So we can say and safely say that it's 0. Along the x-axis, it is not 0. However, from higher to lower, so this is negative acceleration. Okay. So if the velocity is greater, greater, so it means it started greater and then suddenly it ended up way lower. So that means there's a decrease in velocity. A decrease in velocity is caused by a negative acceleration. Um, another way that you will have a negative acceleration is that when it's moving to the left, now it's the opposite of the motion, opposite of the direction of motion, that will cause negative acceleration. So now let us try to start figuring out what is the acceleration along the x-axis. Okay. In terms of F, in terms of mass, of course, this one should have their mass. Okay. Typical information. So this is more of like a review of possible questions you will be asked during the test. So the approach is trying to help you come up with the answer, okay, in a much simple way. So let's solve for the acceleration along the x-axis, along the horizontal axis, and then we have our force. And let's solve for the force. How much force is applied in order to come up with that answer? Okay. Will it be to the right? Will it be to the left? I think there's something wrong with this drawing. Okay. How would that be possible? How would that go slower? Maybe this drawing, this force should be on the other side. Okay. Might be on the other side. So we don't know. So let us prove that it is possible, or this scenario is possible, by applying our skills in mathematics and knowledge in physics. Now, first step, as always, is to draw your free body diagram. You probably know by now that the first step is to present your understanding of the content of the concept using free body diagram. Again, there should be this imaginary line. This is your y-axis and this is your x-axis. Y-axis and x-axis. And there's a dot where all forces would meet as you apply it. First, let's draw the dot right here. We have our first force, which is our force of gravity or weight. And of course, it's on the surface, so there's force along your y-axis with respect to your surface and the object, and that is your normal force. Also, there's a force applied at an angle measured along your x-axis, but you don't have to specify the angle in your drawing. This is your free body diagram. So just the actual forces, no components, no additional information. X force that is acting on it is your force of friction. But since it's moving, then it should be your kinetic friction. Okay, kinetic friction force. Force of friction or kinetic friction force. So that will be your first step. Now, there's no other forces acting on it. Okay, there's no other forces acting on your block. Let us move to the next step, and that is to continue with our solution. So solution. Now let's move to our dots again. Okay. Now move to the dots. I always love the same. Let's move to the dots. So we have our force of gravity, which is downward. Fg is mass times g. And then there is that normal force that is acting upward, F of n. A normal force. And then we have our force of friction or force of kinetic friction. And that is your coefficient of kinetic friction multiplied by the normal force. Then we have our F, the applied force. And of course, since it is applied not along the x or y axis, but it is at an angle measured along your y, along your horizontal axis or your x-axis. So let us draw our dotted lines, red being our y and blue being our x. So this is our f sub x and this is our f of y. And the angle is right here. So it's measured along your x-axis. So we can all say that we will be using for f sub y, that will be f, since it's measured along your x-axis, so that will be f cosine, that's sine theta. And then for our x component, we will be using our cosine theta. Okay, cosine function of the angle because it is measured along your x-axis. Now, let's finalize our free body diagram. Next step, third step. So that is your force of gravity, which is m and g. The normal force, F of n. The kinetic friction force. And then, of course, the two components of your applied force F, which are, first one, it's F of y, and that is F of sine theta, and then this one is F of x, which is F of cosine theta. F of cosine theta. Okay, so let us try to apply our concept, which is the summation of forces along your y-axis, and we all know that the acceleration along y-axis is 0. We still have to write it down anyway, just to come up with our, establish our relationship. Summation of forces, positive going up, negative going down. Okay, so positive going up. So we have normal force, F sub n, plus our F sub y, which is also positive, minus our force of gravity, that is multiplied equivalent to mass multiplied by mass, and the acceleration 0, which is also 0. So F sub n, or the normal force, plus our y component of the force applied F, which is F sine theta minus F of g, which is mass times g, equivalent to 0. Again, I want to express my answer in terms of Fn. So now we have our Fn, and that is, this one is negative. You move it to the other side of the equation, that will turn out to be positive, minus F sine theta. Now, if you analyze it at this point, mg minus F sub n, so you would know that the difference between Fg, so basically the difference between Fg and your Fy is your normal force. Okay, so that's what it meant. Okay, I know I've been doing it for the past couple of videos, and I'm not so sure if I've mentioned it, so I'm just trying to add it as an additional explanation to you. So Fn. Normal force is simply the difference between the force of gravity, or the weight, and the vertical component of the applied force F, which is equivalent to F sine theta. Now, analyzing the different forces acting along our x-axis is equivalent to mass multiplied by the acceleration along the x-axis. Okay. So I know it's almost similar to the previous question. Okay. Previous video, I think it's dynamics number 7. Here, the only difference is that we have to change the acceleration from a to negative a. Okay. So let's see what happens if you have negative instead of positive. So anything to the right is positive, so that's F sub x minus the coefficient force of friction, of kinetic friction, is equivalent to mass multiplied by negative acceleration a. Okay, F sub x is F cosine theta minus F, which is friction, okay, coefficient of friction, kinetic friction, multiplied by the normal force, which is equivalent to negative m times a. Oh, okay, so now it's negative. So why don't we divide both sides by mass, so keeping our acceleration by itself. Okay, so now this will give us F cosine theta minus mu k F sub n over negative m. Okay, so if you notice, I still put negative m. Why don't we just put the parentheses, so we don't forget that it's negative. Okay, so we don't forget it's negative. Okay. Usually I don't use the parentheses if I don't have to. There's multiple variables. The only times sometimes it's easier to remember that you have a negative value if you put your quantity or your parentheses, so that you remember. Okay, so a, or the acceleration, which will give us negative value, by the way. So why don't we plug in the value of Fn? So this will give us F cosine theta minus mu k F of n, and that is mg, minus F sine theta divided by negative m. Okay. So what I'm going to do next is to just distribute mu sub k. I'm not so sure if we have space to write, but let's try it. So this will give us F cosine theta negative mu k mg, negative times negative, so that will give us positive F sine theta over negative m. Okay, so what I'm going to do is remove the negative. So divide positive by negative. But before that, let us combine all those coefficients with the same variable f. So if you don't mind, please follow the arrow. Okay, and then I'll use another sheet of paper for the second part. So further, let's move on. A is simply, so let's pull out f from both sides. Okay, so now we have f, that is cosine theta, plus, okay, plus something I miss, the mu k. So we need to distribute the value of mu sub k, or our coefficient of kinetic friction. So this will give us sine theta, and then we place negative mu k mg, negative m. Okay, so negative m. Okay, so now what we're gonna do, okay, you know what, let me just use another sheet of paper so we can actually see it better. Okay, so what I'm gonna do is transfer this information right here. Okay, so I'm gonna transfer this information, so that will give us a, so what will happen, negative, positive, so I'll remove this. What will happen here is that I will have negative, and then this one will change into positive, negative, positive. So what will happen, I have negative f multiplied by cosine theta plus mu k sine theta. Let me just zoom it in so it's easier to see. Okay. You know this, now I put my negative right there. And here now I have positive mu k m times g, okay, over m. So now this is the difference on our answer earlier from the previous video, where f is positive, this time it's negative. It used to be negative, now it's positive, or we just have to inverse. Okay, so replace the order. So it looks good. We have mu k m of m multiplied by g minus f cosine theta plus mu sub k of sine theta over m. So that's basically the difference between our answer earlier in the previous question. I think that's video number 7. Okay, correct me if I'm wrong. Okay, number 7 was, let me zoom it out. It was positive f, this time it's negative. So that's the difference. Now for letter B, about forces, it is the same process, same step. Okay, same step for letter B. Okay, so let's use this equation right here. Okay, so let's use this equation right here, f cosine theta for letter B. Okay, so this is for letter A. Let me just draw a box around it saying that this is our answer for letter A. So this is the answer for letter A. Now how about letter F? So using this relationship, so for letter B, so f cosine theta minus mu sub k fn equals negative m. Okay, there you go. let me just zoom it in, as we already know where I got this information. Next, let's replace our Fn with this value of Fn, which is mg minus f sine theta. Okay, so again, f cosine theta minus mu sub k mg minus f sine theta equals negative ma. So that's negative ma. Again, f cosine theta negative mu k mg plus, because now you have to multiply it, negative and negative will give us positive, so mu k, or the kinetic coefficient of friction, coefficient of kinetic friction, multiplied by f sine theta equivalent to negative ma. So now we can combine like terms, which is your cosine, or your f cosine theta, and then let's add this mu k sine theta, then minus mu k m and g equals negative ma. Right away, I think you are aware what's going to happen next in terms of manipulating the equation. So let us bring this one to the other side of the equation, giving us positive, from negative to positive value. So that is f cosine theta mu k sine theta is, since this is negative, just keep it as negative. So now we have negative ma plus mu k m and g. Okay, so m and g. So we can pull out our m. So we can say that this is f cosine theta plus mu sub k sine theta is equivalent to, we can pull out m. So now we know that this one, since this is negative, I'll just put it on the other side. So we can say, I just wanted to keep it so you could see, mu k times g, mu k times g. And let's divide it both sides by cosine theta, or the coefficient of f. So this will give us f is equivalent to, I just wanted to clean this. So instead of having negative first, so let's have positive first, which is our mu k multiplied by g minus the acceleration. And that is divided by cosine theta plus mu k sine theta. So if we compare this answer to our answer to the previous, where it's positive acceleration, so we put our acceleration instead of positive into negative first. That's the only difference. Okay. So the numerator is different. So it means the greater the acceleration, okay, the greater the acceleration, what will happen with the force? Okay. The greater the acceleration, what will happen to the force? The weaker the force is. Okay. Or else, okay, what will happen? And if you increase the force, what will happen with the acceleration? You have to weaken the acceleration, or you have to increase the mass. Okay? So if you increase the force, what will happen with acceleration? Okay? It will also weaken in terms of its value, or the direction might change. Okay? So this is your answer for letter B. Okay. Now time, the same thing if you want to solve for time. However, we already know from previous videos. Just go back and review what is the effect of forces in terms of time, in terms of the amount of time needed to accelerate an object. If you increase the mass, just go back to our previous video, or you can use this as well in terms of negative acceleration because of the effect of force when it's acted on the opposite direction. Okay, so here's another video. We will have another video about this. Maybe it has something to do about maybe what if the angle is measured along the y-axis. What's the difference? Okay, or you can just go ahead and proceed with an explanation instead of showing you the entire solution.